gigantic magnetic halo has been discovered wrapped around our Milky Way galaxy. Our little piece of the universe is contained within a vast shell of dark matter. Through the space between the few isolated stars scattered throughout this largely invisible sphere seems empty. There's a lot going out there in the wilds of the Milky Way. By studying hot gas glowing in circumgalactic space, astrophysicists have found evidence of enormous magnetic fields that wind through and around our galaxy's dark matter halo. This work provides the first detailed measurements of the magnetic fields in the Milky Way's X-ray emitted halo and uncovers new connections between star-forming activities and galactic outflows, explains astrophysicist Zhang of the National Institute of Astrophysics in Italy, INAF. He says, our findings show that the magnetic ridges we observed are not just coincidental structures, but are closely related to the star-forming regions in our galaxy. The study was performed on the X-ray light emitted by two huge structures that extend above and below the plane of the Milky Way, discovered in 2020. These Rosetta bubbles extend more than 45,000 light years either side of the galactic center. They're powered by huge outflows of gas and plasma. Shocks in this medium cause the bubbles to glow brightly in the X-ray range. When the bubbles were discovered, scientists thought they were two main contenders for a source. One was activity in the supermassive black hole at the center of the Milky Way. If it went through a period of jet activity, the heat and energy created could have blown the bubbles. The second explanation was starburst activity. The galaxy is pretty quiet now, but it could have undergone a period of intense star formation. That too could have produced enough heat and energy to create the Rosetta bubbles expanding into the galactic halo. Zhang and his colleagues thought that any magnetic fields, if they were present, may have some answers. Light, when it travels through a magnetic field, becomes oriented according to the direction of the magnetic field in what's referred to as polarization. We can examine the light collected by our telescopes to see not just evidence of its polarization, but the direction of the magnetic field that produces it. When the researchers studied the polarization of the broad spectrum of light emitted by Rosetta bubbles, they found huge long filaments of magnetization, and if we could see these filaments with our eyes, they would stretch across the sky up to 150 times longer than the width of a full moon, the researchers say. And the filaments suggest that the origin of the Rosetta bubbles was star formation. At a distance between around 10,000 and 16,000 light years from the galactic center, a ring of star formation could have produced the heat and winds that caused hot gas and plasma to billow out into the galactic halo over a distance of tens of thousands of light years and counting. It's now well known that a small fraction of active galaxies can generate outflows of matter fueled by accretion onto supermassive black holes or by intense star formation events, which profoundly affect their host galaxy. Such outflows are the thought of the fundamental elements in regulating the growth of galaxies and the black holes at their centers, explains astrophysicist Gabriel Ponti of INAF. What I find fascinating in this case is to note that even the Milky Way, a quiescent galaxy like many others, can expel powerful outflows, and in particular that the star formation ring at the end of the rotational center contributes significantly to galactic outflow. Perhaps the Milky Way is revealing to us a phenomenon common in galaxies similar to ours, thus helping us to shed light on the growth and evolution of these objects. It's not a certainty, of course. It's going to take a lot more analysis to make a solid determination on the source of these bubbles. The team's findings are consistent with recent simulations, but more detailed ones will be needed to determine whether star formation can produce the kinds of outflows we observe in the Rosetta bubbles. However, the magnetic fields represent a significant piece of the puzzle. The study opens new frontiers in our understanding of the galactic halo, Zhang says, and will contribute to deepening our knowledge of the complex and dynamic star formation ecosystem of the Milky Way. This was published in Nature Astronomy, and it's on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.